Alright guys, welcome back to another video on derivatives of the inverse trig. We are not going to integration yet because we still need some practice problems on the first principles. This was from a Year 12 Math Extension 1 trial paper. It's in 2025 and the website I used was THSC, if anyone was wondering. So, how would I tackle this problem? So first, you have an inside function of another function, so I would use chain rule. So chain rule states that dy du times du dx equals dy dx. So we need to let some function be u, as stated. So we would let this entire function be u and derivative that. So using quotient rule, du dx is equal to negative sine x. This is just routine. You can skip the video if you want to learn the chain rule more, or if you have problems expanding with the quotient rule, just listen up. Okay, so you've got this function, put it over sine x plus 1. Nothing special. Now you apply the negative throughout and you would get negative sine squared x minus sine x minus cos squared x all over sine x plus 1. So you can see here that the sine squared and the cos squared have something in common, but we need to remove the negative to match the identity. And by removing the negative, you get this. This is your derivative of du dx. Simple enough. Then, we've got tan inverse u equals function x. Don't mind why I put the function x here. There's no specific reason. I just had no space over here. So, now we have y equals tan u. Literally just go through tan inverse of u, my bad, but literally just review that video we just did if you're still confused, but I will just skip the explanations at this point. And tan y equals u dy du equals 1 over 1 plus u squared. We can see that we just made it a single function by using the chain rule. Yes, the chain rule, but this is the power of the chain rule. So whenever you see a tan inverse and you have no idea what to do and you just forgot the formula, you can derive it by first principles. Dy du times du dx. We can see a clear connection here, but we need to see, where's u squared? Where do we find the u squared? But what did we let u squared? First, we let it be this, but we actually need to sub this into the original function we had. This makes sense because dy du, we can make it in terms of this function such that we will multiply and get something nice at the end, I am predicting. So I am going to remove this now, but we will now calculate dy dx. So just to recap, dy du equals 1 plus 1 plus u squared du dx. Yep, I'm doing it correctly. Negative 1 on sine x plus 1. And what was our substitution for u again? U would equal to cos x over sine x plus 1. Alright, very nice. Now all we need to do is apply it, and using my mind, you can just see binomial expansion to sine x plus 1 plus cos squared x all over sine x plus 1 squared. But this is all over 1. Remember that fraction over fraction is sometimes annoying to deal with, but we always have to deal with it in these questions, which means you flip the reciprocal, not that hard. Bam, sine x plus 1. 2. So now you can see something beautiful going to happen. Because you found du dx, you found this, you found dy du, you simplified it, so now all you need to do is combine the functions together. And the reason why we can just multiply, like I said in the previous video, you can treat this technically as a fraction. You can't simply state it in conceptual questions, but when you're thinking about it, just say it's a fraction. It doesn't matter, because no one's going to look at your working out, unless you're in an exam. dy du times du dx. It will just equal to -12. So therefore, f prime of x will simply be -12. Graphing the derivative, y equals -12. Simple enough. Bam. This is the graph of the derivative. Simple enough. Alright.